High voltage overhead lines are the lifelines of the electrical energy network. They transmit enormous amounts of electricity over long distances from the point of generation to the centres of consumption. The decommissioning of power plants associated with the goals of the energy turnaround and the accompanying increase in renewable energy pose a challenge for the existing overhead line network infrastructure. Only an optimally established overhead line network can ensure this. The system developed by SPIE for the aerial survey and inspection of power lines consists of a fusion of different imaging sensors, high-resolution photo and video technology in combination with UV imaging and infrared thermal camera. The light detection and ranging, short LiDAR system, is used for topographic imaging of the overhead power line and its surroundings.
The innovation of our product is the comprehensive data collection by 4 different sensors within one single helicopter flight. In that way we can be cost and time efficient, and the collected data can continuously update existing data.
During the survey flight, a video image is obtained of each overhead line component for visual documentation. Another sensor records the UV range. In the superposition of both datasets, non-visible electrical and mechanical anomalies can be visualized. In parallel, the infrared camera provides data for visualizing thermal peculiarities on the overhead line components, as here, for example, on this ground wire. The LiDAR system scans the corridor of the overhead line in parallel with the other readings. This results in a high-resolution 3-dimensional point cloud of the topography along the route. Based on this, a high degree of automation is possible. Segmentation of vegetation, calculation of short distances, updating of the topography, and even change detection. This innovation enables cost and time-efficient comprehensive data to be collected over many hundreds of kilometers in just one survey flight. These data are transferred to SPIE's own Test and Technology Centre in Langen for further evaluation. The Research and Technology Centre tests and evaluates components and technical systems, especially of high-voltage overhead lines. It works independently of manufacturers and has more than 50 years of expertise, specialising in investigations and expert opinions, particularly regarding overhead line components.
After transfer of data from the helicopter inspection, our AI-based algorithm processes a huge amount of information. Components are marked, localized, and potential defects are highlighted.
Based on this data, the test engineers, as experts in the field, can prepare a condition assessment of the overhead line network. This involves identifying both singularly occurring damage and systematic faults that can affect the entire overhead line network. These abnormalities are recorded and supplemented with prioritizations and recommended measures in charts and diagrams. The AM suite, developed for SPIE's customers, serves as a central module for visualizing and linking the results with inventory data. With all the automation, the personal conversation is very important to us. During the presentation at the customer's site, the recommendations for action are presented and explained, and further measures are derived.
In 2019 haben wir eine EU-weite Ausschreibung getätigt zum Thema Befliegung mit Technik für unsere Stromtrassen, haben dabei den Partner SPIE gefunden und sind uns sicher, mit der SPIE den richtigen Partner an unserer Seite zu haben.
With the multi-sensor data acquisition during the aerial survey, in combination with the highly specialized condition assessment, SPIE creates the basis for efficient management and safe network operation.